Hi everyone, I welcome you to our channel. My name is Professor Kevin. So please, if you haven't subscribed to our channel, please just subscribe now and like the video, and don't forget to share with your friends or your fellow learners. So in this video, we're going to talk about proof by contradiction. So in order for us to prove a statement by contradiction, we prove that the statement is true by showing that it cannot be false. We prove that the statement is true by showing that it cannot be false. So, which means that we need to assume that our statement is false. We assume that the statement is false, and then after assuming, we arrive at some contradiction. We arrive at some contradiction. Remember that contradiction is a statement that is always false. So which means that a first step that you need to do when proving by contradiction is to assume that your statement is false, or is to negate your statement. So if you assume that your statement is false, it means that you arrive at some contradiction. This means that you will see that your assumption is false, because I say that contradiction is a statement that is always false, which means that whatever you would have assumed, you will come to a conclusion and see that your assumption was false. That's how we prove by contradiction. You assume, and then at the end, you disagree with your assumption. So let's say that we need to prove that P is true. We need to prove that the statement P is true. So the first thing here that we need to do is to assume that P is false. That is the first thing, first step. So after assuming, this means that if P, we assume that P is false, or we negate P, it means that not P is true. If P is false, then not P is true. Okay, then after that, after assuming, we'll arrive at some contradiction. It means that we'll see that our assumption is false, then our assumption is not P. Not P, we'll see that is false. So if we say that not P is false, this means that P is true. This represents that P is true. It means that not P, because when you say not P is false, you are still saying not P is true. So if not P, according to double negation, not P is the same as P. So it means that you end up saying that okay, your P is true. So we have proved this statement in contradiction. So let's do a practical example. So let's say we need to prove that root 2 is irrational. We need to prove that root 2 is irrational. So the first thing that we need to do is to assume, or is to negate this statement. Okay, is to assume that this statement is not true, or is to assume that the statement is false. So we're going to say root 2, let's say assume that root 2 is irrational. That's the first step that we should do. We must assume that your statement is false, or we must negate your statement. So remember that rational number, it's any number that you can write in terms of fraction. So which means that root 2 we can write it as a over b, and then we know that a and b must be the integers. Numerator and denominator must be integers, and our b cannot be equals to 0. Again, a and b must be, how to say, a and b are co-prime factors. A and b are co-prime factors. This means that a and b have no common divisor. It means that a and b have no common divisor. So Now we're going to square both sides. We're going to have 2 is equals to a squared over b squared, and then we make a squared to be subject of the equation. We're going to have a squared is equals to 2 multiplied by b squared. And remember that b is an integer, but it cannot be 0 as we indicated here. So it means that, look, here we have a squared is equal to 2 times b squared. So if b is an integer, even b squared is also an integer. So which means that here we are having 2 multiplied by any integer, and then if you say 2 multiplied by any integer except 0, we are going to have even number. So which means that a squared is even because it is 2 multiplied by integer, okay, and excluding 0 because we said b cannot be 0. So which means that hence a squared is even integer because we have 2 multiplied by integer. Okay, so now if a squared is an even integer, we need to find out what about a. Is it even or odd? So remember that square root of a squared is equals to a, right? So square root of any even number will still give you even number. Square root of any even number, it will give you even number. So which means that, okay, a squared, not a squared, a is also an even integer because it's the square root of a even number, so it must also be an even number or even integer. So a is also an even integer. Then it means that you can write a as 2k for some k element of all the integers. So now we need to substitute 2k where there is a squared. So where there is a, we replace 2k. So it means from this statement we are going to say 2k squared is equals to 2b squared. Then we are going to have 4k squared is equals to 2b squared, and then we make our b squared to be subject of the equation. B squared is going to give us 2k squared. So this means that even b squared is going to be an even integer. Hence, b squared is even integer. And if b squared is even integer, which means that even b is going to be an integer. So b is also an even integer. And then it means that b can be equal to 2 multiplied by r, where our r for some r element of all the integers, okay, where our r is an integer. So now we have seen that a is an even integer, also b is an even integer. So this means that our assumption was false. How do you know that our assumption was false? Remember, in our assumption we said a and b are co-prime factors, or we said a and b have no common divisor. So if both of them are even numbers or are even integers, it means they have a common divisor. It means they have a common divisor. They are not co-prime factors. They are not co-prime factors. They have a common divisor. So it means that our assumption was false. So we can say this contradicts A and B being co-prime factors. Why? Because since A and B are divisible by 2, remember, even number or even integer is any number that can be divisible by 2. So if A and B are divisible by 2, so it means they are not co-prime factors. They have a common divisor. So if they have a common divisor, so it means that our assumption was false, because in our assumption we said A and B, they have no common divisor, which means that they are co-prime factors. So we have found that, okay, A and B are not co-prime factors. Okay, it means our assumption was false. So we say, okay, therefore our assumption was false. So if our assumption was false, so it means that our statement is true, which means that the root of 2 is irrational. So this is how we prove a statement by contradiction. You first assume that your statement is false, and then at the end you will conclude that your assumption is false. You will see that your assumption was false. So if your assumption was false, it means that your statement is true. This is our proof. I hope you've enjoyed this video. Please do not forget to like and subscribe to our channel. Thank you.